circle C has equation x minus 1 all squared plus y plus 3 all squared is equal to 25. Point A has got the coordinates 6, 9, and point B lies on the circle. We need to find the minimum distance of AB, the maximum distance of AB, and then the length of AB when it is a tangent to the circle. So there's quite a lot of information given here, and it's quite difficult to work this out the way it's been given to me at the moment. I'm finding it quite difficult to visualise exactly what's happening here, where point B is, where point A is, I'm not sure. So I'm going to draw a sketch, so I've got a better idea of what's actually happening. So let's draw a set of axes first. So there's my y-axis, my x-axis. Right, the circle, I know the centre of the circle has x coordinate 1 and y coordinate is minus 3. The 1 coming from here, the minus 3 coming from there. And I know the radius of the circle is the square root of 25, which is 5. So let me mark that onto my set of axes. The centre is 1 minus 3. And if the radius is 5, then it's going to look something, I'm just drawing this really roughly. It's just a sketch to help me visualise what's happening. Something like that. Right, the point A has the coordinates 6, 9, which is going to be roughly up here somewhere. And then point B lies on the circle, but I don't know where. So B could be here, or it could be there, or there, or there, or there. B is somewhere on this circle. I don't know where. Right, I want to work out the minimum distance of A to B. Well, the minimum distance that A to B would be is if B was, let's see if I get this right, if B was here. If B was anywhere else, if B was here, then clearly that distance there is going to be longer than this distance. So that is where B is going to be when I want the minimum distance. Well, how could I work that out, considering I don't know the coordinates of B? Well, I can work out the distance from A to the centre of the circle. That's pretty easy because I know those coordinates, and I can use the distance formula for that. So let's do that. Let's work out the length of that line. So we'll do the change in the x coordinates squared plus the change in the y coordinates squared, all square rooted. That's how we work out the distance between two coordinates. And when we do that, we get 5 squared plus 12 squared, all square rooted, which is 13. So the length of that line, the length of this green line here, is 13. And remember that I know that this is the radius of the circle, which is 5. So if the green line is 13 and the yellow line is 5, then that means that the distance from A to B is 13, take away 5, which is 8. Part B, the maximum distance of A to B. Well, where is B going to be if we want the maximum distance? Well, it's going to be the other side of the circle. It's going to be over here now. This length here is going to be the biggest that AB can be. Again, if B was here, for example, then this line here is clearly not as big as that red line. What's the length of that line? Well, I worked out a moment ago that this green part here, the length from the centre of the circle to the point A was 13. And we know that this is the radius of the circle, which is 5. So therefore, the distance AB, the whole length of that line is 13 plus 5, which is 18. And then part C of this question. We want to work out the length of AB when it is a tangent to the circle. So where is B going to be if AB is a tangent? Well, let me mark on a tangent. Now I could draw my tangent here like this, or you could draw your tangent here. It doesn't really matter either way. The length of the line that we are going to work out is going to be the same in either case. So, my tangent is going to touch the circle here. That's where B is going to need to be in order for AB to be a tangent. So that's where B is on the circle here. And I want to work out the length of AB, this length here. Now, one of the key things about tangents is that they are perpendicular to the radius. So this is 90 degrees. Also remember that I worked out previously that this length here was 13. And I know that the radius is 5. So to work out the length AB, notice we've got a little right angle triangle here. Let me just highlight that right angle triangle. So we can do a little bit of Pythagoras. The length AB squared plus the radius squared is equal to the hypotenuse squared. And you can see that it's going to give me 12 here. We've got a 5, 12, 13 triangle. And so that's the answer for part C.